Hey everybody, it's Mr. N, and we are going to talk about Newton's method today. Mainly for us, we're going to be using our calculators a lot on these to do the math, just because it goes out to many decimal places. But real quick, right here, when you use your graphing calculator to find the roots, your calculator is using something called the Newton's method. Really, it's the Newton-Raphson method. And to find zeros, it's using a form of this, let's just put it that way. And to find zeros, here's what you've been taught. You set the equation equal to 0, you solve for x. So that's basically how we're finding zeros. When your calculator is doing it, it's using this other method, which I'll talk about in a second. Then we went further and we developed something called the quadratic equation. So if we had a quadratic, y equals ax squared plus bx plus c equals 0, we were able to derive this formula. Now this comes from, one of the proofs is using the completing the square method to get this formula. But basically that's what we use. And there are formulas for x to the third and x to the fourth, but they're quite complex, they're quite long. I'm not going to write them in here because it's really difficult. Then this guy came along, the Norwegian mathematician Niels Henrik Abel, from 1802 to 1829. He was really young. Look at that, 27 years old. And that's what he looked like. And he proved that it is impossible to construct a formula for a fifth degree or higher polynomial. So he proved that if something is fifth degree, so we do have an equation for the third, we do have an equation for the fourth, but they're really long and complex. And he came along and said, hey, that's about all we can do. Anything larger than that for fifth and higher, there is no formula that can be developed to be able to get the roots. So then how the heck do we get the roots? Well, if you factor it, you can get it. If you have something like this, it's extremely difficult. But Newton, in the 17th century, developed some sort of estimation method. And here's what Newton said. Let's scroll this up. He said, suppose we have this graph. Let's move him as well. And we're going to pick a point, x1, comma, f of x1. So we have our graph here, and we're going to pick some point, x1, f of x1, right there, okay? And I want to find this root right here. Well, if I draw a tangent line, okay, it's going to intersect right here at x2. Okay, come up, find what the value of x2 is. All right, so we have x2, f of x2. Draw another tangent line. You get another one. Draw another tangent line. You get another one. Draw another. Guess what you're ultimately getting? As these tangent lines, they will converge. They will get smaller and smaller, and they will, for your x, and then they will be this root. So you repeat the process. You start with the first one, repeat the process, draw the tangent line, call it L2. L2 crosses at x3. Continue to repeat this process until you get that 0. So notice how these are converging, and they'll come down to where the 0 is. So the slope we're going to call f prime of x, so we relate this to x1 and x2. Y minus f of x1 equals f prime, there's your slope, times x minus x1, since the x-intercept is equal to x2 now. And we end up with 0 for the y. So x2 would be here, and 0 for the y, because we haven't gone any height. You solve this, you end up with this. You can't have f prime of x equaling 0, because you can't have a horizontal tangent. That defeats the purpose. So we end up with this formula to use right down here after I generalize these values. But let me explain to you what we're going to do with this formula, because there are some caveats to it. So over here, we end up with this formula, and then after we continue to use this sequence, it's going to converge. It'll converge at some limit, but it may not converge. Because suppose you do end up with this and you have that horizontal tangent and then you get stuck right there. Or something happens and you start going the other direction. So basically, you need to pick a value. You pick a starting point. Over here, I picked the starting point at x1. If my value that I picked, randomly picked, was a good one, it'll converge. If the value that I randomly picked was not a good one, it won't converge. That's the situation. So if it doesn't converge, then you just pick another x value to start with. That's your second try, do it again until you get something that converges. Now, what do I mean by converges? Well, we're going to do the calculations here, and I'll show you. So let's move on to the next page. And we are going to use Newton's method to approximate the solutions of this. Let me enlarge this a little bit so we could see it a little bit better. And I'll show you how this process is done. So let's first start off by taking the derivative of this equation right here. So we're going to say f prime of x equals, this will be 3x squared minus 1. Why am I taking the derivative? Because I need to find slopes, right? And we know that from our formula, x sub n plus 1 from the previous page equals x sub n minus f of x sub n over f prime of x sub n, okay? So let's put in some values here. We know that x of n plus 1 will be x sub n, and minus, now here's my original equation. This is x sub n cubed minus x sub n minus 1. All I did was put sub n here for my first iteration, or whatever value I choose. And that derivative now will be 3x squared, so x sub n minus 1. Now, I'm going to randomly pick an x sub 1. Randomly choose x sub 1. And I'll just pick 1.5. And the reason why I picked 1.5 is I'm just trying to get something close to 1 over here, right? That'll give me a 0. I'm just guessing. And if I don't choose correctly, you will see that the values don't converge. If I do choose correctly, they will converge. All right. I will put this into my equation. So x sub 2 will be my x sub 1 value, which I chose to be 1.5, minus, now this will be 1.5 cubed minus 1.5 minus 1, all over 3 times 1.5 squared minus 1. And I put this into my calculator. And I get an answer of 1.347826087. In this method, you're going to want to carry it out as far as your calculator will let you. And I'm going to show you something in a second that will make this a little bit easier. So then you want to find x sub 3 now. What do you do with x sub 3? Well, you have to put in what your x sub 2 value was. So that would be 1.347826087 minus, this is my x sub 2, right? I'm going to put it in here. I don't have room to write it, so I'm going to put my x sub 2 cubed minus my x sub 2 minus 1 all over my 3 times my x sub 2 value squared minus 1. And I will get, for x sub 3, I will get 1.32520040. Okay? I have to keep doing this until these numbers right here match, until my x sub 2 or x sub 3, x sub 4, x sub 5, as I keep going, my numbers match. Well, that's a lot to do on your calculator. But here's how you can make that process a little bit easier. So we know what our equation is, and this hasn't changed up here. So let me use a different color. So this hasn't changed. All right, we know what that's going to be. We know that this, and we know this. So what I'm going to do is I'm going to put 1.5 in my calculator. I'm going to take my calculator out. Okay, so here's my calculator, because I can't, with the software, it's too hard to pop it into the screen here. And I'm going to put 1.5, and I'm going to hit enter. Okay, so 1.5, enter on your calculators. Then the next step, you're going to put second answer. You're going to use the answer feature on your calculator. And here's what I mean by that. Here's the quick graphic of your calculator. You have this button right here, that's answer. So you're going to hit second and then answer to access that, okay? So that's what I'm saying when I say answer. You put 1.5, enter, and that stored the answer. So you want to recall that answer, so you're going to hit second answer. Okay? So that's what you do on your calculator. Let's move this out of the way. So it'll be second answer, and then you're just putting the equation in one time. So you're going to say minus, then you're going to say answer cubed minus answer minus 1. Basically, I've put in this part of the equation so far. Let me highlight the part that I've put in. So basically, I've put in this right here and this so far. Now I just have to divide by. Oops, let's use the right pen tool. I have to divide by, and this is 3 times, and open parentheses though, 3, open parentheses, 3 times answer, you're going to do squared minus 1. Then just hit enter. Okay, it'll give you this value. Then hit enter again. It'll give you this value. Then hit enter again. Each time you hit enter, it's using your previous answer and putting it into this equation that you just put in right here. So it's saving you time from having to do this equation multiple times. So you just do it the one time, 1.5 enter, that's your guess, and then answer minus answer cubed minus answer minus 1 divided by that. Okay, then enter, then enter, then enter, and each time you will get the next value. So that meant you got, let's change the pen here a little bit, you got originally 1.5 for your x sub 1. That's what you guessed. Then x sub 2 came out to be this value right here. Then x sub 3 came out to be this value right here. Then x sub 4 is going to come out to be approximately 1.32, 471817. X sub 5 will be approximately 1.32, 471796, and x sub 6 is approximately 1.32, 471796. Notice how these two converged right here. We got the same exact answer, so that meant that's your answer. So that's the answer for this particular solution, for this particular problem. There's one of your roots. So one of your roots is, and you've done other methods like synthetic division, all factoring and all that, but this is if none of those work. You want to try doing it this way. So this is the Newton method. And so your answer for one of the roots, remember this may have 3 roots, and then you can try to find the other 2. But for one of the roots, x is approximately 1.32471796. Now, if I graph this, I will get this particular situation, and this crosses right there at right here at 471796, and the other 2 will end up being imaginary. So yeah, we can use our calculators obviously now to find roots, but this is what they did when they didn't have the graphing calculators, and this is the method your calculator is using. Now, the catch here is I don't want you to have to do this all the time, and they're not going to technically put it in this manner on the AP test. So you can use your calculator to give you a little hint of what your initial guess would be, and then do this method to find all the zeros, okay? But use your calculator, graph it, and then just say, oh yeah, this is between 1 and 2. Okay, so I'm going to guess a value of like 1.5. So just use that to give you a little head start. So let's do another one. Let's see what we got here. Oops, let's move this up. Okay, and we can take a look at what we have here. And let's go back and change my pen color again, and let's see. Use Newton's method to find to 3 decimal places the x-coordinate of the point of intersection of the first quadrant of these 2 equations. Okay, so the intersection. So what do I want to know when I want the intersection? That's when they are equal to each other. So in this case, I've got these two equations, and I want to know when 1/3 x equals the sine of x. So really what I'm trying to do is I'm going to multiply everything by 3 here just to make this a little bit easier. 3 sine x. So really what I want to know is this situation, 3 sine x minus x, when that equals 0. It's just easier to do if there's no fractions. So this is really my f of x equation. I need an f prime of x so that I can use Newton's method, and this is going to be 3 cosine x minus 1. So x sub n plus 1 will be x sub n minus 3 sine x sub n minus x sub n over 3 cosine x sub n minus 1, right? The f of x over the f prime. And again, you can go back and see how I developed the formula. It's pretty simple. We just put in zeros, right, for the y and then the x plus 1. So I'm going to guess now. If I guess x sub 1 equaling 1. So I'm going to hit 1, enter on my calculator, right? And then I'm going to put in answer minus, open parentheses, 3 sine answer, right? Because that's my x that I chose, minus answer, close parentheses, divided by, this will be 3, open parentheses, cosine answer minus 1, close parentheses, and then hit enter. So I will get an x sub 2 value of negative 1.45514. Hit enter again. I will get an x sub 3 value of negative 0.39648. Hit enter again. I'll get a value for x sub 4 of 0.53771. You keep going, and these are not converging, which means I chose a bad value right there. So we got to do it again, and I will choose an x sub 1 this time. This is trial number 2, right? Our second try at this. I'll choose an x sub 1 value of 2. So now I got to go 2, enter, right, and then put the equation in. And again, there, like I said, there might be a copy and paste way of doing that. And I will get an x sub 2 value this time of 2.3237. I will get an x sub 3 value of 2.2796. I'll get an x sub 4 value of 2.2789, getting closer, and I'll get an x sub 5 value of 2.2789. So it converged after 5 iterations for this value, and this is my root for this equation. This is my solution. X is approximately 2.279. All right, one last problem for us to do. Use Newton's method to approximate this to 7 decimal places. When you see a problem like this, and this is how they did these cube roots, 5th roots, 6th roots, 7th roots. Basically, back in the day is what I'm saying. So basically what I need to do is I have to make this a function. And how do I make this a function? Well, I can say what this really is x cubed minus 123 equals 0. Right? Because if I set this equal to 0, or set this equal to x, sorry, x equals this, and solve it, that's what I end up getting. Cube each side, subtract it over, you end up with this value. So your f of x is x cubed minus 123. Your f prime of x will be 3x squared minus, or that's it, just 3x squared. And so then x sub n plus 1 will equal your x sub n, whatever you choose to guess, over x minus, this is going to be x sub n cubed minus 123 over 3 x sub n squared, like that. Okay? And then here, let's go ahead and choose, I'm going to choose 5. X sub 1 equals 5. So that means x sub 2, when I put it in, I'm going to say 5, enter, in my calculator. Then I'll put in answer. Just one more time to remind you guys, open parentheses. Answer cubed minus 123 divided by 3 answer squared. Okay? That's how we're going to do that. And so then x sub 2 equals 5 minus this 5 cubed minus 123 over 3 times 5 squared, right? That's what this was. So x sub 2 comes out to be, and I'm save you the hassle here, 4.9733 repeating. X sub 3 comes out to be 4.973189. X sub 4 comes out to be 4.973189. And we are all set. So there's your x. 4.97311898. Take your calculators out and then try that. Try the cube root of 123. You will get that answer. So that's kind of cool that it works out that way. But this is the Newton method. Newton-Raphson method is what your calculator is using to be more precise form of it. But that's how we do it, and that's this method. So thanks for watching. Hit that like and subscribe button, and I'll see you guys in the next video.